All right, this entire lesson is basically a bunch of theorems. We're proving theorems about perpendicular lines. So these are all just giving you reasons why perpendicular lines are what they are. This is how mathematicians proved them. So, Theorem 3.8 tells you if two lines intersect to form a linear pair, whenever you hear the word linear pair, think on the same line. They are next to each other on the same line. Of congruent angles, then the lines are perpendicular. See how you have the linear pair here? Oh, that highlighted in gray, weird. Linear pair next to each other forms a perpendicular line because these two angles will have the exact same measurement. Okay, Theorem 3.9 says if two lines are perpendicular, then they intersect to form four right angles. Okay, the key there is if they are perpendicular. So you have to have at least one of those little red boxes showing that it's a 90-degree angle. Then you'll know that all four of them are 90-degree angles. Any questions about those theorems? All right, so let's look at an example. I'm going to take a picture. You can draw it. It's a pretty simple little drawing. All right, so looking at this diagram, it tells you, I'm telling you, that the book's telling you, AB, line AB is perpendicular to line BC. What can you conclude about angle 1 and angle 2?
They're linear.
What else can you conclude? They are 90 degrees. That's the first thing I would conclude, yes. So if they're 90 degrees, then how many of these are 90 degrees?
How did you know 2 is 90 degrees?
Because it's perpendicular, so it bisects it perfectly.
Okay.
So then we know that angle 1 and angle 2 are right angles. Which also means that angle 1 is congruent to angle 2. And you would say because of Theorem 3.9. All right, let's look at another theorem.
Theorem 3.9.
3.9 was the last one. So now we're going to look at 3.10. If two sides of adjacent acute angles, what's acute mean? Less than 90. If two acute angles are perpendicular, then the angles are complementary. I can't say that word sometimes. So they're telling you if the two sides of two adjacent acute angles are perpendicular, translation, if this side is perpendicular to this side, then we know that the angles are complementary. If we know they're complementary, then we know they add up to what?
90.
90. Very good. Let's look at example 2. Actually, I'm going to take a picture real quick. Maybe not. Okay, try not to look at the answers as we go through this. They want you to prove that if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So we're basically proving Theorem 3.10 that we just read. So you do that by writing statements and reasons. number 1 should be the easiest.
Can you just not theorem 3.10? And that's it.
No, they're wanting you to actually prove 3.10. This is what they did to make this theorem. So number 1 is what? What's the reason?
Given.
Given, always. So, number 2, so we're trying to prove that angles 7 and 8 are complementary. So what can we decide, or what else does it tell you here? Yeah, you see the right angle, so you know that those two intersect, right? They're perpendicular. So for number 2, we can say angle DEF is a right angle. I'm just abbreviating because I don't have enough space. That's RT angle, right angle. And we know that because of Theorem 3.9, the one we read a minute ago. Shows that perpendicular lines intersect to form 4 right angles. Okay, so then we can say that the measure of angle DEF is what? 90. And the reason on that one is that's the definition of a right angle if it's excuse me. All right, so now let's look at the 2 angles that we have here. We have the measure of angle 7 plus the measure of angle 8, which is the measure of angle DEF, right? And we know those add up to the big angle because of the angle addition postulate. Okay, now if I want to say the measure of angle 7 and the measure of angle 8 equal 90, what did I just do? Okay, I have the measure of this one, angle of DF equals 90, and then I have the measure of 7 and 8 equals DEF. So I just, basically, I took the 90 and I plugged it in here, right? What's that called?
Substitute.
Yep. Substitution. And that leads us to what we want to prove, which is that angle 7 and angle 8 are complementary. Terrible handwriting. And that's the definition of complementary angles, because they add up to 90. And that's how they got Theorem 3.10. You're like, why do I care? I know the Theorem 3.10. It's good to practice your proofs. It's good for your brain. All right, let's look at the next. We have Theorem 3.11, which is the perpendicular transversal theorem. You notice we have two parallel lines and a transversal again. You guys remember when we were dealing with those? So we know that these 2 lines are parallel because it has those 2 little arrows. And it tells us that if a transversal is perpendicular to one of the 2 parallel lines, then it is also perpendicular to the other. Seems pretty self-explanatory. Theorem 3.2 tells us in a plane, if two lines are perpendicular to the same line, then they are parallel to the other. So this is essentially the reverse of the first one. See how it has the two perpendicular lines? Then we know that these two angles are parallel. Okay? You're just going to use that to help draw conclusions. So let's look at example 3. So we have our diagram. Determine which lines, if any, must be parallel in the diagram, and explain your reasoning. All right, so looking at these, which ones can we say we know are parallel?
PQ.
PQ, because you see these two right angles, right?
Mm-hmm.
And then we have the transversal cutting through it. So what theorem proves that?
3.12.
Yep, theorem 3.12 proves that one. Any other ones? Any other lines are parallel?
ST.
We have this, yep, this right angle across this line. So S and T are also parallel. And why are they? What theorem proves that one?
3.11.
Still 3.2. We did the exact same thing. Two right angles on a transversal. Good. Bless you. All right. The last thing is to find the distance from a line. The distance from a point to a line is the length of the perpendicular segment from the point to the line. Let me show you this. So let's look at, I'm going to read this again. The distance from a point to a line is the length of the perpendicular segment from the point to the line. So you see how they had a line already drawn, line K, and then they had a point A. All they're saying is the distance, if I were to draw a perpendicular line straight to that point, that's the distance. Okay? All right, so now we can talk about the distance between two parallel lines. The distance between two parallel lines is the length of any perpendicular segment joining the two lines. So you see how these join and this joins? That's the distance between two parallel lines. You can use any one of those. I know that was kind of redundant. Okay, so let's look at example 4. I'm going to take a picture.
Oh, why am I putting that acid?
Okay, so we have a sculpture. It's drawn, they put it on a graph for you, so you can see the units are measured in inches. What is the approximate length of segment SR? So let's find SR. So here's S and there's R. So it's the one side of one of the chairs. Okay, does everybody follow that on the screen? It's basically the depth of the seat. So in order to find the length of a perpendicular segment, you can use the distance formula. Woohoo! Do you guys remember the distance formula?
No.
So first we have to find the slope. So you use these 2 points. So we're going to have 120 minus 110. I don't think it recorded all of that. Am I recording now? Yep. It's approximately 18 inches. Okay, for those of you in YouTube land, this did not record because the student interrupted me. So you use the distance formula, you plug in the points for the x and y, and solve. So yeah, it comes out to approximately 18, what label, inches. So the distance, the depth of the chair is approximately 18 inches. Okay, so make sure if you didn't remember the distance formula, I do believe you use it in your lesson. So write it again, maybe in this top of your page so you have it. All right, any questions? She asked, why did I find the slopes? And because we did. We found the slope is negative 2/3 and 3/2. And remember, to find perpendicular, one of them, they multiplied to come out to be -1. But the easier way to see that it's the opposite, meaning it has the opposite sign, and it's the inverse. So they are opposite inverses of each other. So we knew they were perpendicular, therefore we could just calculate the distance.
Why did we find the slopes?
That's a good question. It told me to. You need to find the length. Oh, you needed to make sure it was perpendicular. And you saw that they were opposite inverse. Look at that. Great. All right, so you need to do numbers. I forgot already.
12 through 10 and 15 through 24.
And 15 through 24. All right.